Good day, everyone. Welcome back to our YouTube channel. As you know, we are going to be teaching you chemistry today, and we are going to be taking the first topic in chemistry, which is introduction to chemistry. Chemistry, as we know, is a study of matter and the changes that occur to matter. As we know, chemistry is the subject or is the cause that determine or that describe the changes that occur to matter and the changes that occur to it. So, as we all know, the first thing we need to take a look at introduction to chemistry is the scientific method. What is the scientific method? As we know, science is a study of change. There is always a new change in town. So how do we know that this thing is correct or this thing is wrong? How do we postulate theories? How do we make laws in chemistry or in science? That is what we know as the scientific methods. The first thing in the scientific methods is the observation. A scientist, when you look at your environment or you are doing something in your lab and you notice some things, that some irregular things or some things that you have not been noticing before, the first thing is that you observe. Then you see patterns. You see patterns. Okay, why is this thing working this way? Why is this thing doing like this? Why is this going right instead of left? Then you see the patterns. You perform the experiment the first time, it gives you a right hand side something. You do it the second time, it gives you a right hand side the second time, the third time same thing, the fourth time same thing. So you've noticed the patterns. So the next thing you do is you write an hypothesis about it. You write an hypothesis. What is an hypothesis? An hypothesis is a should I call it an unconfirmed theory or a theory that have not been practically confirmed. So what do you do next after you get an hypothesis? When you are noticing the patterns, you might try it at a time and it might not work. And that's when you experience problems. When you experience problems, you try to work against or work behind your problems. Then it will be able to give you your hypothesis. And after your hypothesis, the next thing is you do experiments. Chemistry or science is a branch of study that deals a lot with experiments. You do a lot of experiments. So the experiment is going to give you two things. What's the first thing is, if your experiment is showing positive results, if your experiment is showing positive results, if your experiment is giving you positive results, science does not stop there. It will still science will tell you that you need to go on to make further experiments. Science will continue to tell you that you need to make further experiments. You're not going to, it's not because you've made experiments and you see a positive result, then you just tell us that this one is like this. Automatically you don't know what you are doing. So you need to continue making experiments to prove what you've seen or what you've noticed. So if it gives you negative results, then you know that what you need to do is you'd have a new or modified hypothesis. You understand? Once you've been able to go around your results, you are going to get a new or modified hypothesis. Then from the new hypothesis or the modified hypothesis, you make further experiments. When you make further experiments and they give you positive results, then you are going to have a theory. Before you have a theory, if you have positive results all through, you are going to have 1-2 experiments. continuous experiment. You are going to do your first and second experiments continuously, and a a theory that has been proven and that has been extensively tested, and it has given us positive results all through or every time, is what we know as a law. If you've tested your theory, you test it a lot of time continuously, over and over again, and you've seen positive results all through, even generations after you, they have tested it and they see that it's very very correct, then that becomes a law. So next thing to do here, we'll be going to uses of chemistry. When you are a chemist, or you are studying chemistry, or you are even learning chemistry, what are the things, what are the importance of chemistry to our human life? The first thing is food. The introduction of organic fertilizers or non-organic fertilizers, and insecticides. Introduction of insecticides and fertilizers have been able to help chemists or help farmers produce more food. Insecticide, fungicides, herbicides, or any other thing you want to say, they are works of chemists who have dedicated almost all their life to it. Another uses of chemistry is clothing. The introduction of man-made fibers have helped reduce even the burden of using cotton or natural materials in making clothes. Man-made fibers like nylon have been produced by chemists, and people are using it as clothing. Another uses of chemistry is military, or another contribution of chemistry is military and space science. Chemistry has been able to help military by the production of gunpowder, bombs, atomic bombs, and all other sort of things that they help in defending our countries or our territories. And in space science, chemistry has helped produce rocket fuels, jet fuels, and every other thing they need outside the space. Foods that cannot decay or spoil when they take them into outer space, they've been produced by chemists. Another use of chemistry is in medicine. Drugs, pharmaceuticals are products of the pharmaceutical industries that have based their life on chemistry. If we have importance or uses of chemistry, automatically we should have the adverse effect or the disadvantages of chemical processes around us. One of these disadvantages or one of these adverse effects is number one, rusting of iron. Iron, when exposed to air, that is oxygen and water, it will start rusting, forming an oxide of iron that is brownish in color. How do you protect iron from rusting? Number one is protective coating. Application of protective coating to the surface of an iron might prevent or protect it from rusting or from corroding. The protective coating can be like a paint or a layer of grease that you put on it that will prevent it from having direct contact with air and water. The second way of protecting iron from rusting or from corrosion is galvanizing. Anywhere you hear the word galvanizing, they are talking about zinc. You can use zinc as a protective metal on iron because zinc does not corrode. If you put zinc, or if you electrolytically put zinc on the surface of an iron, the iron will not corrode. The third one is sacrificial metal like zinc, like copper, and other aluminium that do not corrode. Other metals that do not corrode, you can use them as protective coating or as as sacrificial metal for your iron to prevent it from corrosion. And the third one is alloying. Iron can be alloys with a lot of compounds or with a lot of elements. An example of it is steel, which is a mixture of iron and carbon. This is the formula for steel. So this kind of compound or this kind of alloy do not corrode because of the presence of carbon there. Another adverse effect of chemistry is pollution. Chemistry has produced or has been able to give us a lot of hydrocarbons and a lot of compounds that are useful to our environment. But when these compounds are not properly disposed, or when these compounds or when these substances are not properly disposed, they will start polluting the environment. One of these compounds or one of these substances is crude oil. Crude oil, chlorofluorocarbons, nitrous oxide and nitric oxides and other oxides of sulfur, they are pollutants to the environment even in small quantities, and if they are not properly disposed very well, they can cause adverse health conditions. Another adverse effect of chemistry is drug abuse. Drugs that have been provided or have been produced by chemists for healing purposes, they have been misused by youth and some other adults, and they started using it in such a way that they have not been ordered or they have not been told to use it that way. You understand? So that is one of the adverse effects of chemistry. So the last thing we are going to take in introduction to chemistry is careers in chemistry. Some of you might be thinking that, okay, I love this course, I like this subject. What are the career purposes in chemistry? If I become or if I study chemistry in the higher institution, where can I work or where can I use it? One of these is the first one is the teaching service. You can become a teacher or a lecturer in any tertiary or primary or secondary institution where you'll be taking students who like or love chemistry. Another one is you can work at the health centers or the health sector. Production of drugs, they are works of industrial chemists and pharmacists. So you can work as an industrial chemist or a pharmacist. And the third one is agriculture. You can help farmers produce fertilizers, insecticides, fungicides that they need to improve their growth. Even you can help them reduce the acidity of their land or help them reduce the basicity of their land. And if you can even give them alternatives to fertilizers, there are manures which are chemically produced. You can help them and produce such a thing. Thank you so much. Thank you for watching. Make sure you like, subscribe, and share our videos. Share to your friends that are writing JAM next year and see them pass.